Hi, welcome to IPv6 routing lessons, IPv6 routing protocol security. After we finish the IPv6 routing protocol dynamic and static configuration, in this lecture, in this lesson, we are going to give a clear idea about how to secure the IPv6 routing protocols configure, and we will focus on the dynamic routing protocols. We will learn about some important topics: threats against interior routing protocols and IPv6 routing protocol security, and we will learn how to configure passive interface and how to limit prefix list advertised or received by routers, and we will use cryptography to authenticate the messages exchanged among the routers inside the networks. Okay, there are some dangerous threats against interior routing protocols, especially the dynamic protocols. Simply, a router is a special purpose computer that is optimized for forwarding packets toward destination. The routing protocols that run on routers are applications, and these applications are listening to the network that can be vulnerable to attack, just like any software that can be running on a network. Therefore, the routers are susceptible to disruption attacks to consume their computing resources, and buffer overflow attacks, just like any other computers. Routers could be disrupted and their traffic rerouted in undetermined ways, and this means router could be controlled by attackers. Routing loops, black holes, and network partitioning, all these could create DOS situation. That means a router is vulnerable to attack of DOS type. The attacker typically has a goal to put himself in the path of the traffic flow, to perform man-in-the-middle attack. So we can say that the router is vulnerable to attack of man-in-the-middle type. Okay, now for the security of the IPv6 routing protocols. Routing protocols are intended to work in a friendly environment where all the routers are cooperating between each other for the common goal of speeding the convergence times. Because many routing protocols were not designed to operate in attacked environment, they initially lacked authentication or confidentiality features, and that is why a special care should be taken to secure routers and their routing protocols after we configure the routing protocols. Because of weaknesses in routing protocol, you should consider the security of routing themselves on a network. And this actually could be done using some configuration commands. Here we are presenting some recommended tasks using configuration commands to secure IPv6 routing protocols. Number one, passive interfaces configuration. Number two, limiting of prefix list advertised or received by routers. And number three, using cryptography to authenticate the messages distributed or exchanged among the routers inside the network. Okay, let us start with the first recommendation, which is passive interfaces. A passive interface in a router is an interface that is able to listen to route updates, but it cannot advertise them. So it just receives the updates. It is best practice to use passive interface command, configuration command, and to disable the router from sending messages where routing updates are not needed. For example, outside the network, we don't need for the route updates to go outside the network. So we have to set any interface as a passive to prevent any specific actually or selected interface as a passive interface. This is important on what we call access LANs. Access LAN is a LAN that is connected to organizational network through an interface. So this interface, we can call it like entry point, should be passive. This is important on access LAN interfaces where the subnet is placed into the routing information page as a valid connected route, but for security reasons, for routing protocol does not need to send updates out to the LAN, to this access LAN. Here is an example of how to configure some interface as a passive interface and how to verify the configuration. First, we just need to go inside the router mode. This example, of course, about the OSPF, Dynamic Routing Protocol. First, we need to go inside the routing mode. Then we can set all the interface as a passive. Then we can exclude from the passive configuration any interface that we want to set to exchange the route updates. And here we have two commands just to verify the configuration. Here we say no passive interface for the S00 and for S01. We need these two interfaces to send and receive any route updates inside the network. And here we want to verify the configuration. So just set the passive interface feature for some interfaces, then you want to verify the configuration. Okay, now we want to do it. Now we want to practice the setting of passive interface. So let us do it in GNS using our global topology. Okay, now we are going to show how to configure passive interface. In this topology, we have 4 routers, R1, R2, R3, and ISP router. These 4 routers should exchange route updates between them. But we don't need any updates to go outside the topology. For example, especially here in this network, in this access LAN, we don't want any updates from inside the topology go outside the topology here in this network, which is 2001 db8 CE00:1::. So we are going to set this interface, which is F00, as a passive dummy interface. This will make this interface to receive any updates, but it will not advertise the update received outside the topology here in this access network. Okay, well, of course, I will not explain how to enable the routing protocol, because I already explained it in some previous video. So you can go back to OSPF configuration video in this topology to learn how to configure the OSPF v3 for IPv6. So I will do it by copy and paste here for router 1. Okay, copy, good. For router 2, this is router 2. Okay, and router 3, I want router 3. This is router 3. Okay, now for the ISP router, okay, that's good. Before setting the passive interface, I will try to ping just to be sure that our configuration successfully done. From router 1, I will ping this interface, which is this one here. Ping 2001:db8: CE00:1:1. Okay, that's mean our configuration for the ISP v3 here in our topology done successfully. So we want now to prevent this interface from advertising any internal route updates outside the network, this interface. So I'll go to ISP because it is in ISP router, and I will execute these commands here. First, configure terminal, then go inside the router mode IPv6 router OSPF1. Okay, then set passive interface feature for the fast Ethernet 00. Okay, that's all. And now if I want to be sure that this interface is set as a passive, I need only to execute this command, show IPv6 OSPF interface F00. Let me make it a little bit bigger. Okay, I can see here no hello updates. That means it is now passive interface. If I check for the other interface, which is yes, 00 S00 here. Okay, show IPv6 OSPF interface 00. I cannot see this no hello passive interface here in the output of this command, because it's not set passive. So this interface will receive and advertise any root updates, while this interface will only receive no advertisement of the root. Of course, you can do it. For example, if you need for this interface, or for this interface, or for this interface, if you need, just you need to execute this command. Configure terminal, go to inside the router mode, then set the interface as a passive, and that's all. And you want to verify the configuration of the passive interface, you need to execute this command.